Hello, this is the Genuine Approachable Sudoku for the 4th of March 2024. Oh, I'm sorry, the text says 3rd March now, but this is for the 4th of March 2024. It is Difference Arrow by Clover, and you'll notice some arrows here that don't follow the regular rules. So let's look at the rules. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Each circle in the grid has 2 arrows attached to it, so you can see this one has 2 arrows attached to it. The circle tells you the difference between the sum of digits on one arrow and the sum of digits on the other arrow. So for example, this 5 here is to say that the difference between the sum of these two digits and the difference between the sum of these two digits and this digit is 5. So if this was like a 1, for example, don't just ignore that, this would sum to 9. And if I made this a 4, ignore that, they would be differing by 5. So yeah, those are the rules. It is a little complicated, but I think we can work through it. Alright, those are the rules. With that, let's just begin solving. Let's start with this then. Yes, because the 3 here means that those differ by 3. So those two digits have to sum to 5. Because this is 2, this must be 5 or minus 1. It can't be minus 1, obviously. So it must sum to 5, but can't be 2, 3, so it must be 1 and 4. We can do the same here, where these must sum to either 1 or 5, but it can't sum to 1. So it must sum to 5 without using 2, 3. It has to be 1, 4 again. And actually we can resolve that. So 1, 4, this one also resolves that for us. Okay, what's next? This 2? No, this, yeah, it's the exact same. Those digits must be exactly 5. Because they can't be 3. They differ by 1 from 4, so they're either 3 or 5. But if they were 3, they would have to be made of 1 and 2, which is not possible because 1 is already in the box. So they must sum to 5, but they cannot use 1 and 4, so they must be 2 and 3, which is resolvable. And the exact same applies here, because the 1 here means that must be a 5 to differ by 4 exactly. So there you go. The 2 here resolves that. Now what do we have? Maybe look at this, this 2 maybe? Well, that doesn't really tell us much. I guess the 6 might be a bit more interesting, because those differ by 6. Meaning one digit is at least 6 higher than the other. And we know that it can't be 4 or 3 in any of those digits. So there must be one digit that is from 1 or 2, right? Yeah, in fact, because of the 1 and 2 here, none of those digits are 1 and 2. So 1 and 2 must exist in one of those cells. And because they can't both be in those two cells, because they don't differ by 6, 1 or 2 must appear in here. One of them must be here. Okay. Now, let's see. Maybe we could do this. Yeah, this digit is at least a 6, because it can't be 1, 2, 3, 4, or 5. Yes, and because that digit is at least 6, this is at least 14. This digit is therefore at least 9, and therefore has to be 9. So there you go. That leaves us with 7 and 6 as our final digits. And maybe we can tell what this is. No, not 7 and 6. 7 and 1. And this one actually resolves that. So there you go. Now those digits differ by 1. Those digits have to be 5, 8, and 9 to finish the box. And so this is either an 11... wait a minute. Yes, this has to be an 11. It's either 11, 14, or 15. But because this is 2 away and must be one digit, it only has to be 11 with 9 over here. If it's any bigger, you can't fit this digit into like one digit. So it has to be 5 with a 9 here. And it gives us all of that. This digit and that digit differ by 1. So if this is an 8, this could be 9 or 7. Can't be 9, so it must be 7. If it was a 9, then this digit would have to be 8. Okay. Now what? 4... No, 6 in this box by regular Sudoku goes here because of those 6s. And now this digit is 3 away from that digit. We know this sums to 11, so this has to be 8. Now those digits are 7 and 9, which doesn't do anything. Actually, those digits are 5, 7, and 9, but 5 can't be in those cells, so 5 must go up here. So that forms another 7-9 pair, which helps us resolve this 8-9 pair. So this must be 8, that must be 9, which is next to 8, to differ by 1. Now, those digits are 3 and 7, and this forms a pair of 2, 4, and 6, I believe. And this can't be 4. Now, there might be something to do with this digit, but I don't think we can figure that out just yet. Alright. Those digits are 7 and 8. That is resolvable. 8, 7. Now those digits have to be 5, 6, and 9. 5 can't be here or there by virtue of those 5s. So 5 must be here. 6 here resolves the remaining thing. Now this is 12. So to differ by 4, this must be 8. Oh, not 7, 8. Those digits are 6 and 9. Nice. Actually, this 6 resolves it, but I can also say this can't be 9 because two 1-digit numbers cannot differ by 9. They can only differ by at most 8 if you use 1 and 9. Alright, now we can probably look at those. Actually, we might just look at those two. 7 and 8, sorry. And so this I don't think can be 7 because that will be forced to be 1, which breaks. So this must be 8, which is next to 2. This 7 here resolves all of this. And that is a pair. 4 and 5? Yes, 4 and 5. Meaning those digits form a triple consisting of 1, 2, and 7. Now those must differ by exactly 6, so they cannot be 2 something, they must be 1 and 7. This 7 resolves that for us. 7, sorry. Cool. 2 and 6 here mean that must be 4, that's awesome. Now those two differ by 4. Can I tell which digits they are? Probably. So, it's pretty hard to say. Let's do the rest of the Sudoku first. Those have to be 1 and 6, which is resolvable. Those digits are 3, 4, and 8. And for them to differ by 5, they must be 3, 8. Now 3, 8 is resolvable by this 3 down here. Jeez, okay. Now more Sudoku. This has to be 6 and 7. No, 7 and 9, which is resolvable. 7, 9. This 7 resolves this. 3 here, 7 there. Those digits have to be 1, 3, and 5. I think it's a chocolate teapot. This can't be 1, this can't be 3, that can't be 5. It is a chocolate teapot. Now those digits have to be 1, 3, and 7. This can't be 3 or 7, so that's 1, which resolves all of this. This now can't be 3 or 1, so it's 7, giving us our last digit here. I guess now we have to use these digits to help us. Yeah, because what? I mean, that forms a quadruple, right? Should I use that? We're missing, I guess we're missing a 9 somewhere. Yeah, 9 in this column, I guess, must be here because of those two 9s. So those digits have to be 4, 5, 2, 4, or 5. And to differ by 3, they must be 2 and 5. So that gives us this. 2, 5 is resolvable. And in fact, that helps us resolve this pair over here. The last 3 digits have to be 4, 6, and 8. And let's just use these arrows one more time. For these two to differ by 4, they have to be 4 and 8. And this 4 itself already helps us disambiguate that, giving us our last digit. Yeah, solving the puzzle in 7 minutes and 50 seconds. I like this. This is a very new idea. Alright, well I hope you enjoyed this video. I'll see you guys next time. Bye bye.